Welcome back, dear students. Today we'll be starting a new chapter, and the name of the chapter is Pythagoras Theorem, chapter number 13. Right, so before we begin with the problems from exercise 13a, let's understand what is Pythagoras Theorem. Okay, so what is the statement of Pythagoras Theorem? That's what we are going to do at first. Right, so we have the statement says, for any right triangle. Okay, so I'm not going to explain you the statement for now. So whenever we deal with Pythagoras theorem, first and foremost, what we need to keep in mind is we need to always work with a right angled triangle. For example, you see here this triangle. What kind of triangle is this? This is a right angled triangle, and you know this is always 90 degree, right? So in a right angle triangle, one of the angle is always 90 degree, and the side opposite to 90 degree is always called hypotenuse. Okay, so this is the main thing that you need to keep in mind. All right. Okay, so now in each and every side of this right angle triangle, okay, so I'm going to draw square. For example, if I take this side, consider this hypotenuse. Using this hypotenuse, I am going to construct a square. So you see, I have constructed a square out here. Okay, so this gray colored square is made using the side hypotenuse of the right angled triangle. Now similarly, apart from the hypotenuse, you have got two more sides in the triangle. One is this side, and I'm naming this side to be A, and I'm naming the other side, the leftover side, to be B. Or in other words, what you can call it is, you can call this as perpendicular, and you can call this to be base. Using these perpendicular and base, again I'm constructing two more squares. So using perpendicular, I have constructed a red square, and using the base, I have constructed a blue colored square. Okay, now if I ask you to find the area of each square, see, we have got three squares now. So if I ask you to write down the area of these three squares, now you know formula for calculating area of a square. Area of a square is nothing but side square. This is the formula. Now what is the length of each side of this square? It is h, isn't it? So that's why it becomes area of this gray becomes h square, side square, that is h square. Similarly, we have for the red square, side is given to be a, isn't it? So that's why the area of this red is a square, and similarly the area of this blue becomes b square, because each side of this blue square is how much? B. So that's why area of this becomes b square. Okay, now according to the Pythagoras theorem or Pythagorean theorem, the area of the biggest square, you see the biggest square is this one. So the area of biggest square will be equals to the sum of the area of the other two squares. So the other two squares are a square and b square, and their sum turns out to be a square plus b square. So this sum will be equals to the area of the biggest square, which is h square. So this is the Pythagoras theorem. Okay, so this is the statement of Pythagoras theorem, or sometimes you can call this to be hypotenuse square is equals to perpendicular square plus base square. So this one and this one both represents the same, and they are called Pythagoras theorem. Okay, so you will pause the video and make a note of the statement of the theorem. Let's see the first question. So we have the first question on the screen, which says a ladder 13 meter long rests against a vertical wall. Okay, if the foot of the ladder is 5 meter from the foot of the wall, find the distance of the other end of the ladder from the ground. try to understand this situation. So there is a ladder which is kept or which is resting against a vertical wall. So let me show you the diagram out here. Okay, so the diagram looks somewhat like this. So we have, you see, this AC represents the wall, okay, and this AB represents the ladder. Okay, now it says ladder 13 meter long, so the length of the ladder is given to be 13 meter. Okay, so this ladder is resting against a wall. Now it is said that if the foot of the ladder, see, this is the foot of the ladder, okay, so this foot of the ladder is 5 meter from the foot of the wall. So this is the foot of the wall. So the distance between foot of the wall and foot of the ladder is given to be 5 meter. Question is asking you to find the distance of the other end of the ladder from the ground. So this is the other end of the ladder. So you have to find its distance from the ground. That is, you need to find this. Okay, so let me write down the solution for you. So let AB be the ladder resting against the wall. Here the wall is AC, isn't it? AC. So therefore we have AB is given to be equals to how much? 13 meter. Okay, and we have been given BC. Okay, BC is given to be 5 meter. Okay, now in triangle, see, in triangle ACB, you have angle C equals to 90 degree, right? Angle C is 90 degree. So that's why this side opposite to 90 degree, that is AB, becomes my hypotenuse. Okay, so therefore by Pythagoras theorem, so what you are going to have is, by Pythagoras theorem, hypotenuse is square, so hypotenuse is AB square. So we have AB square is equals to AC square, perpendicular square, plus BC square, that is BC squared. Now let's put the values out here. So AB is given to be 13, so this is 13 square is equal to AC. AC is given to be, no, AC is not given, so we will find what is AC. So we'll write AC as it is, plus we have BC square. What is BC given to us? BC is given to be 5, so that's why it becomes 5 square. So from here, this is 169, 13 square is 169. We have AC square plus we have 5 square, which is 25. So from here you have AC square is equals to 169 minus 25, which is 144. Remember, you are asked to find what is AC, right? So therefore from here you get AC equals to square root of 144, which is equals to how much? Square root of 144 is 12, isn't it? So therefore your answer, that is AC, turns out to be 12. Here the unit that we are making use of is meter, so that's why your answer is 12 meter. Okay, so you may pause the video and note down your solution. Let's move to the next question. So question says, a man goes 40 meter due north and then 50 meter due west. Find his distance from the starting point. Okay, so the situation is somewhat like this. So if A is the starting position, then what happens is, from A the man moves 40 meter due north. So towards north you have to move 40 meter, and after moving 40 meter you have to move 50 meter west. So 50 meter west. So you have moved 50 meter west and you have reached B. Now you have to find his distance from B to the starting point. That is, you need to find this. Now if you look at this, this is again 90 degree. Okay, so let A be the initial or starting position. Okay, let C, so let C be the position after moving how much? After moving 40 meter due north. Okay, and let B be the final position after moving how much? 50 meter due west, right? So we need to find what? This distance, isn't it? Distance between the initial position and the final position, which is AB. Okay, now in triangle ACB, again in triangle ACB, you see angle C is again 90 degree, isn't it? Now if angle C is 90 degree, then this becomes a right angle triangle. So that's why using Pythagoras theorem, we get, okay, so we have hypotenuse, this 90, side opposite to 90 is always hypotenuse. So we have AB square is equals to perpendicular, you can call it, so AC square plus we have BC square, right? So you need to find AB, remember. So we have AC is given to be, AC is 40 square, right? BC is given to 50, so we have 50 square. So this turns out to be 1600 plus this turns out to be 2500, isn't it? So add them up, you get 4100, isn't it? So this is your AB square, so that's why your AB, okay, so your AB turns out to be root over 4100, which turns out to be, so when you simplify this turns out to be exactly 10 root over 41. So your unit you are making use of here is meter. So that's why your answer will be 10 root over 41 meter. Okay, you may pause the video and note down your solution. Let's take question number 3 now. So question 3 says, in the figure, okay, in the figure we have angle PSQ. So angle PSQ is given to be 90 degree. Okay, so this is given to be 90 degree, right? PQ, okay, PQ is given to be, so PQ is this one, is given to be 10 centimeter. So this is my 10 centimeter now. QS, okay, so QS means this is given to be 6 centimeter, and RQ, that is RQ means this much, is given to be 9 centimeter. Okay, you need to find what is the length of PR. So basically, if you observe this diagram, there are two right angle triangles, isn't it? So there is a smaller one and there is a bigger one. There are two right angled triangle here. All right, so let's see what you need to do here. So first and foremost, we will consider triangle PQS. Okay, so triangle PQS is there. Now in this triangle, this is 90 degrees, so side opposite to this becomes PQ. So PQ acts like your hypotenuse. Okay, so that's why when you apply Pythagoras theorem to this, you get your Pythagoras theorem to be PQ square is equals to PS square plus QS square. Simple, right? Hypotenuse square is equals to perpendicular square plus base square. Okay, now let's see what are the things that we know. So we know what is PQ square. PQ, so PQ is given to be 10, so that's why it becomes 10 square is equals to PS. Do we know PS? No, so PS is kept as it is, but QS is known. QS is equals to 6 centimeters, isn't it? So this becomes 6. So when you simplify this, okay, so first and foremost you get 10 square is 100, 6 square is 36. So bring it out here, you get PS square equals to 100 minus 36. Okay, now first and foremost, how much is this? So when you simplify this, this will turn out to be exactly 64. So if PS square is 64, then PS will be don't write this, so you can write root over 64, which is equals to 8. All right, so we have PS. Okay, so we got this PS to be how much? 8 centimeter. You are using the unit to be centimeter here, right? Now, in order to find PR, question is asking you to find PR, isn't it? So in order to find PR, you have to make use of this biggest right angled triangle here. Okay, so let's see what do we need to do here. So we'll consider now triangle PRS. Forget about this middle line. So in this PRS, in this biggest triangle, if you apply Pythagoras theorem, see, this is the 90 degrees, so side opposite to this is the side PR. So hypotenuse becomes your PR, so that's why you get hypotenuse square, that is PR square, is equals to perpendicular square plus base square. Okay, now look at this PR, we need to find it. RS, so RS is this entire thing, isn't it? So how much is RS? RS is RQ plus QS, which is 9 plus 6, isn't it? Okay, so 9 plus 6 is 15. So that's why in place of RS, I've written 15 square plus PS. PS just now you found it to be 8. So it becomes 8 square. Now simplify this. This is how much? This is 225 plus 64, isn't it? So that's why you get here, when you simplify this, okay, so when you add this and find the square root, you get your answer to be 17. That is PR turns out to be 17 here, right? Okay, so let me write down here how much do you get here, right? So you get 289, remember? So your PR, you get this to be root over PR square is 289, so that's why PR will be root over 289, which is 17, right? That's what you need to find here. So that's why you have length of PR equals to 17 centimeter, right? So you may pause the video and note down your solution. Let's observe this question now. So question says the given figure shows a quadrilateral ABCD. So you have a quadrilateral ABCD. Forget about this line. Forget about this line. So if there is no line like this, then ABCD becomes a quadrilateral, isn't it? Right. So we have ABCD is a quadrilateral in which AD is 13 centimeter. So AD is given to be 13 centimeter here. So this is 13 centimeter. DC is this one, which is given to be 12 centimeter. We have BC. Okay, so BC, this is given to be 3 centimeter. This is given to be 3 centimeter. And angle ABD and BCD, they are given to be 90 degree. ABD and BCD, they are given to be 90 degree each. Okay, you need to find what is the length of AB. Okay, so again, before we find AB, you have to see, if you want to find AB, you have to make use of triangle ABD. But in triangle ABD, I know only one side. I don't know other side. So for finding BD, I'll be making use of this particular triangle. Okay, using this triangle. So if this is your 90 degree side, opposite to this is this one, isn't it? So that is BD becomes your hypotenuse for triangle BCD. Remember this. So for triangle BCD, BD is the hypotenuse. Okay, so we have, if you look at the solution, we will consider triangle BCD, and from here you see that BD is the hypotenuse, so that's why you get BD square or DB square, both means the same. So hypotenuse square is equals to perpendicular square plus BC square. DC is given to be, remember, 12 and BC is given to be 3. So put the values, so you get this to be equals to 144 plus 9, which is exactly how much? Which is exactly DB square is 153. Okay, so DB square we got to be 153. Now we'll consider triangle ABD. Now in this case, this is 90 degrees, so side opposite to this, that is side AD, acts like hypotenuse. So that's why your Pythagoras theorem for this triangle becomes AD square is equals to DB square plus BA square, right? Okay, so remember you are asked to find the length of AB. Now what is DA? DA is given to be, DA or AD is given to be 13. Okay, so we have 13 square. dB square, we got this to be 153 plus BA square is kept as it is, as we don't know BA. 13 square is 169, bring this out here, you get minus 153. So when you subtract, okay, when you subtract, how much do you get? You get 16, isn't it? First and foremost, you get 16. So BA square is 16, so that's why BA will be root over 16, which is equals to again 4 here, right? So that's why you are asked to find the length of AB, isn't it? So that's why the length of AB turns out to be, BA or AB turns out to be 4 centimeter. Pause the video and note down your solution. So this will be the last question for the day, which says AD is drawn perpendicular to the base BC of an equilateral triangle ABC. So if you look at this or if you understand this question, there is an equilateral triangle ABC, okay, and AD is drawn perpendicular to base BC. So see, AD is perpendicular to BC. Basically this means that this is 90 degree and this is also 90 degree, right? So we have given BC is 10 centimeter. So BC, this entire thing is given to be 10 centimeter, remember, okay. You need to find the length of AD. Now BC is 10 centimeter. What does this mean? This means that one of the side is given to be 10 centimeter, and since this is an equilateral triangle, this also becomes 10 centimeter and this also becomes 10 centimeter. Now you need to find what is the length of AD. Correct to 1 decimal place. Let's see how to do this problem now. So we have, since triangle ABC is an equilateral triangle, therefore all the sides of the triangle are of the same measure and the perpendicular AD will divide BC into 2 equal parts. It means in case of equilateral triangle, whenever you draw a perpendicular, what happens is this perpendicular will bisect this side. So basically this and this, they are equal in this case, okay. So we have given BC is 10 centimeter, so that's why this and this will be equal and they will be equals to, each of them will be equals to 5 centimeter. Remember, this is 5 centimeter, this also becomes 5 centimeter, this whole thing is your 10 centimeter, remember, right? So we will consider triangle ABD for now, okay, triangle ABD. So if this is 90, side opposite to this, that is AB, becomes your hypotenuse, and this is the main thing, right? So if you apply Pythagoras theorem to this, you get hypotenuse square, that is AB square, will be equals to AD square plus BD square, right? So let's put the value now. AD, okay, so first and foremost AB is given to be 10, so it becomes 10 square, and BD is given to be 5, so this becomes 5 square. So bring it out here, you get 10 square minus 5 square. Simplify this, okay. So when you simplify this, you get, this is 100 minus 25, isn't it? So you get, when you simplify this, 100 minus 25, which is 75. So AD square is 75. So that's why when you find AD, it will be exactly root over 75, and when you evaluate it, when you find the square root of 75 using division method, remember, which you have learned in your class 8. So when you simplify this, you get your answer to be 8.7, okay. Why I am finding only till 1 decimal place? Because question is asking you to find only till 1 decimal place, right? Okay, so we got AD, isn't it? So that's why we say that the length of AD is 8.7 centimeter, because the unit that we are making use of here is in centimeter, okay. So with this, we close for the day. Thank you very much.